So now for example number 4, I have a perfectly drawn circle, and let's think of, this is a story problem in your textbook, of an aquarium, right? So this is a fish tank, an aquarium that is circular in shape, all right? And then we're going to apply some of these properties to solve a problem. So we'll label this as D. We'll label this point over here as B. And then we'll label a point over here as C. So basically we have a secant line, all right? And this, I think, is, we can label this as E. And we're told that, and then we'll have a tangent line. And we're told that this tangent line is 20 feet. And that this segment from E to C is 8 feet. And then this is obviously the radius of the circle. Okay? And what they want us to find out is, what is the radius of the tank? So this is kind of a neat thing, and we use this a lot in science. The radius of the tank, well, we use it in science because, like, a radius of an aquarium we could do easy all day long. We can just take like a tape measure and just measure across the diameter and then divide that by 2. So we gotta simplify the problem that I do for you guys. But NASA does this to figure out the diameter of a planet. So if they know that this planet is here and then there's another planet that's really far away, and they can calculate the tangent distance versus the secant distance. Or another example of this would be like, can I figure out where the satellite is positioned in space? They could use a laser to measure this distance, and they could use a laser to measure this distance, and they can calculate the diameter of the planet, or if they know the diameter of the planet, they can calculate. So this relationship is applicable in real life, and you know, literally rocket scientists use this. But we're going to say aquarium. A fish tank. So we want to know what the radius is. So this problem is the same property that we just used. Basically, we have our tangent line squared, which is CB, and then the short segment times the long segment. So that would be CE times the long segment, which would be CD. All right, so let's plug that in. CB squared is just 20 squared, is equal to CE, which we know is 8, times the quantity CD. Well, that's 8 plus R plus R. So I'm going to say 8 plus 2R, right? R plus R is the same as 2R, right? 1R plus 1R is 2R. So I'm going to push this through. 20 squared is 400. 8 times 8 is 64. Right? And then 8 times 2R is 16R. I probably should stick to the lowercase r. Your textbook, I think, has a capital R. I put a lowercase r. So then I'm going to subtract 64 from both sides. That gives me 336 is equal to 16R. Divide both sides by 16. And I get 21. 21. And that's basically it. Let me slide it up.